All right, today let's talk about slope in context in relationship to our linear programming problems. Our essential question says, how do I define slope in context? So here's just an example to get you thinking about it. So let's just say we had this relationship between the number of home runs, the players' total at bats, and after looking at the data and performing the linear regression like we did in day 4, we got this equation, y equals 4.5x plus 13.1. So the slope of this line, based on the equation, the slope of the trend line is 4.5 or 4.5. We have that right there above in the equation. But what does that really mean? What does that tell us in the context of this situation? In other words, how do we relate it back to the number of home runs that that player has versus the player's total at bats? And that's what we're going to take a look at today. And I have a sentence frame that I'm going to want you to write down in just a little bit that's going to help you write basically just a sentence that describes the slope in the context of any situation. So let's just start with a reminder of what slope is. Slope is the change in y over the change in x. And as a reminder, y is the dependent variable and x is the independent variable. Okay, we're going to need to remember that for our next step here down below. So our sentence frame, anytime we want to put the slope into context, is we're basically saying the following sentence, where we have to fill in the blanks or the parentheses and decide if it's an increase or a decrease. So we would say for every whatever the x variable is, or the independent variable, the dependent variable, the y variable, is going to either increase or decrease by a certain amount, and that amount is the slope. Now, how do you tell if it's an increase or a decrease? It increases if the slope is positive. It decreases when the slope is negative. Let's look at an example. When comparing student heights and weights, the regression equation was y equals 5.5x minus 225.6. So we can see in our equation the slope is 5.5, but what does it mean? So with that slope of 5.5, remember that really means 5.5 or 5.5 over 1. And in this case, we always look at slope as the change in y over the change in x. Remember our slope formula, rise over run from previous unit. Okay, so how much the y changes, and the y variable here is the weights. In other words, pounds. So we're saying it's 5.5 pounds for every one of the x variable, which in this case was heights. And how do we measure height? We measure it in inches. So for our slope, that really is 5.5, means it's 5.5 pounds per inch. So to put it into our own context, it says for every inch, there's our x variable. For every inch that a student grows, their weight, there's the y variable, and it increases because our slope was a positive 5.5, not negative. It increases by the amount, 5.5 pounds, 5.5 pounds. For every inch that the student grows, their weight increases by about 5.5 pounds. That's what this slope is referring to in the context of this situation. Here's another one. When studying the number of times a student checks their phone during class to their class grade, the regression equation was y equals negative 3.5 times x plus 85.77. So again, what is the slope and what does it mean? Well, in this case, the slope, or m, was negative 3.5, negative 3.5. So let's think about what are our variables. Okay, it's the y value is changing by 3.5 for every one of the x. So in our statement up here, it says that we are studying, I guess basically the number of times a student checks their phone to their course grade. Okay, so in terms of graphing, we'd have their, let's call it phone checks, would be the independent variable on the x-axis, comparing that to their grade, which would be the dependent variable on the y-axis. So how do we measure grades? Well, we measure them in percents. So we're saying it's going to be a decrease, because it's negative, of 3.5% for every one time that they check their phone. So here's how we could say that as a sentence using our sentence frame. For each time that a student checks their phone, their grades decrease. I guess we don't need that plural there. Their grade decreases by 3.5%. This time we use the word decrease because the slope was a negative number. If the slope is positive, we would use increase instead. So putting slope in context is really just a way of explaining how the slope is affecting your variables. Let's look at one last problem. This time we're kind of going to go through the whole process to see how we get that slope and what it actually means. So here we have, it looks like we have some passing attempts and number of yards for some quarterbacks. So we've got a quarterback threw 39 times, had 192 yards. Another one threw 39 times, had 290 yards, and so on. So to find the slope of the regression line, we are going to need to use Desmos. So we're going to open up Desmos graphing calculator. We are going to add a table of values, and I'm going to enter my data. Could double check and make sure all my numbers are correct, because the worst thing you can do is enter the wrong numbers, go through all of the work that we need to do, and do it the wrong way. All right, so we have our data in there, but I don't see any points plotted. If I hit the zoom fit, the magnifying glass, now I can see it a little bit better. It kind of jumps around here a little bit. Looks like overall it's a positive trend, even though it doesn't look like a very strong correlation. Let's perform the linear regression using Desmos and that equation. So y1 squiggle mx1 plus b. All right, so we can see here that we have an R value, a correlation coefficient of 0.4819. So that's kind of in the middle between 0 and 1.0. That would show a weak correlation. It is still positive. There is still some correlation. It's just not very good. And we can see that because some of our data points are a long ways away from our trend line. But we do have a trend line, and we do have the slope and the y-intercept of that trend line. So what was it we needed again? The slope of the regression line, which was 8.35833. 8.35 is what I'm going to just kind of round that to. The slope is about 8.35. And you know what? I'm going to even round that further. Let's just call it 8.4. So what does the slope mean in the context of this situation? Well, because slope is the change in y over the change in x, okay, and we can write any slope as a fraction by putting 1 underneath. Just keep in mind, the y variable kind of goes with the top of your fraction. In this case, that's going to be your yards. And your x variable label goes on the bottom. That's your passing attempts. Because our slope was positive, it looks like we have an increase of about 8.4 yards for every one attempt. All right, for the second part of our lesson today, we need to talk about causation. All right, causation is different than correlation. So our essential question today is to answer, does causation prove correlation? So let's take a look. What is causation? Well, causation is the act of causing something else to happen. Or you can also think of it as the relationship between a cause and effect. So I love this graphic here because it really describes what's happening here and the difference between correlation and causation. It says when studies find an association between two things, that's correlation. Just shows that they are related. But that does not mean the same thing as saying that one thing caused the other thing to happen. All right, so just because there's a relationship between two variables or two things doesn't mean that one causes the other to happen. One thing might cause something to happen, or it might seem like it causes something to happen, but correlation is not how we show that. Okay, that we can't prove it using correlation. All we can prove with correlation is that these two things, these two variables, are related, that there is a relationship between the two. Not necessarily a cause and effect relationship, but just that they're related in some way. So the big takeaway for today is we can't prove causation with what we're doing in this unit. It's just not possible. There'd have to be some other type of scientific study that you have to do, and that's not what we're doing in Algebra 2. So correlation versus causation. Again, correlation shows a relationship between two sets of data. That's it. It only shows a relationship. It doesn't explain why it happens. It doesn't try to prove that one causes the other. It's just showing, hey, look at the data. The data kind of lines up, meaning one of these is related to the other. Causation is explaining that one thing causes the other to happen, which is a completely different thing than correlation. So let's take a look at this graph here. And in this graph or scatter plot, we can see we're comparing the number of sunglasses sold from anywhere from about 100 up to around 240 sunglasses sold. And little triangles are our data points. And it looks like we're comparing that to the ice cream sales of that day, or maybe this is at a store, some type of business that sells sunglasses and ice cream. So the first question is there correlation? And as we look at the graph, we'd probably say absolutely. Yes, I do feel like there is correlation. We're just showing that the two variables are related. Because if we were to draw a trend line and kind of match that by drawing, there's a pretty good trend line or line of best fit that matches the data. We have about the same number of points above and below the line, and the points are pretty close to line, close as we can. So absolutely there's correlation. Okay, and what is the correlation of this problem? We're showing that as the number of sunglasses sold increases or goes up, so does the ice cream sales. I suppose it would be that, when you're selling more sunglasses, it's probably nicer outside. And when it's nicer outside, more people buy ice cream. Okay, that's just a correlation, just showing that these two things appear to be related to each other. Now, is there causation? Okay, remember, causation means that one thing causes the other to happen. So do the ice cream sales go up because people are buying sunglasses? No. It might be a complete coincidence, but correlation never proves causation. Okay? Just because there's a relationship in the data doesn't mean that it's a cause and effect relationship. So we're always going to answer the causation question with this statement. Correlation never proves causation. Here's another one. This time, the points are a little bit more scattered. Looks like we're comparing the quality of some type of object or product, and we're comparing it to its price. So we can see a general upward trend. If I were to make a line of fit, a trend line, it'd probably be something like that. It's not a very good one because look at all these data points that are really far away from that trend line. But if I move the trend line one way or the other, those points are going to get further away from the trend line. So I can't really change a whole lot about it. It's just not a very good trend. So is there a relationship? Yes, I would say it is positive. If you look at my trend line, it's rising upward. My R value estimate, it's not going to be very good. It's going to be in that probably weak correlation area. My independent variable, independent is always on your x-axis, so that's quality. Let's see if that one comes. There it is. And price is your dependent variable. And is there causation? We can see there's correlation. It's not great, but they appear to be related. The price is related to the quality of the product. But does it cause it? Does the quality of the product cause the price to either go up or go down? No, we can't say that. One thing might seem like it has an impact or a cause and effect relationship on the other, but we can't prove that with correlation alone. It just doesn't work that way. So we always have to say, no, there's no causation, because correlation cannot prove causation.